Hi, everyone. So today's lesson is going over section 7.1, adding and subtracting polynomials. The previous day in class, we talked about multiplying polynomials. So we're kind of backtracking a little bit with some more basic operations and just identifying the terminology involved here. So you'll see at the very top, one type of polynomial is called a monomial. This is simply a number, a variable, or the product of a number and one or more variables with whole number exponents. So as you can see, here's 4 examples: 3x squared, negative 2abc cubed, 10 is considered a monomial, xy is considered a monomial. What you don't see here is any addition or subtraction operations. Because remember, addition or subtraction would indicate more than one term. So again, a monomial only has one term, hence the prefix mono. Just keep in mind, again, it's got whole number exponents. The 10 works because that is an exponent of 1. Same with x and y, and so on. So if we had x to the 1/2, that would not be considered a monomial. X to the negative 3 would also not be considered a monomial. So really I should add whole number positive exponents. Well, really non-negative. Because if 0 is an exponent, that will work. Remember, anything to the 0 power is just 1. Next, we can identify the degree of a monomial based on the sum of the exponents of the variables. So to the left, you see 4 different examples. Now, the number 100, this would be degree 0, since we could put a variable here, but it would be to the 0 power. In the second example, notice our exponents add up to 4, so this would be degree 4. In the third example, this is degree 3. And in the last example, this is also degree 4 because of this invisible 1 exponent. Next, we identify the term polynomial. So as we said before, a monomial is a polynomial, but also any sum of monomials. So in this example, this polynomial is made up of 3 monomials, but we're taking the sum of all 3. So one term is 2x squared, another term is 4x, and the last term is 3. We generally write polynomials in standard form. This just means that it's written so the exponents of a variable decrease from left to right. So, for example, notice we have x squared, 2x, and then minus 1, but really that's x to the 0 power. Furthermore, there's something called a leading coefficient, and this is simply the coefficient or the number in front of the variable of the first term. And the first term would be the term with the highest exponent. So the leading coefficient in this example is the number 5. Now we can identify the degree of a polynomial by recognizing the greatest degree of its terms. So this is a little different than degree of a monomial, since a monomial only has one term, so we only have to focus on that. Whereas a polynomial, we only want to focus on the term with the largest degree. So if we put this polynomial in standard form, notice we now have the largest degree out front, so its leading coefficient is 4, and the degree of the entire polynomial is 3. We can also identify polynomials by their names. So as we said before, a monomial is simply a polynomial with one term. A binomial is a polynomial with two terms, hence the prefix bi. And a trinomial is a polynomial with three terms, hence the prefix tri, meaning three. So we can identify each of these three examples by the number of terms, so either a monomial, binomial, or trinomial, and its degree. So in example 1, 12x minus 4, notice there are two terms, 12x and negative 4. So two terms means this is a binomial. And the degree would be 1 since that is the highest exponent or the largest exponent. In example 2, this is a monomial since it is only one single term and it is degree 3 since 3 is the largest exponent and really the only exponent. And in example 3, this is a trinomial since we have three terms, and those terms would be 3x squared, negative 2x, and 1. And this has a degree of 2 since 2 is the largest exponent. By the way, the leading coefficient in example 3 would be this number 3. And in example 1, the leading coefficient would be 12. So we've seen adding polynomials before. It was just never formally discussed, but all we're doing is combining like terms. So in this example, as you can see, I put a rectangle around the terms that have x cubed. So if I add those together, I have a total of 8 of them, so 8x cubed. Put a circle around my x terms. I have negative 3x and 5x. So if I combine those, I get 2x. There is nothing to combine with 2x squared, so that remains the same. And the same goes for 2. There's nothing to combine with it. So my final polynomial, and down here I've written in standard form, is 8x cubed plus 2x squared plus 2x plus 2. And this would have a degree of 3. Also, notice this has 4 terms, so we would just simply call it a polynomial. Anything with more than 3 terms would just be a polynomial, poly meaning many. We can also subtract polynomials, as we know. And the only difference here is that we have to distribute the negative 1. And when I say that, I'm referring to this part right here. And that's simply because you must subtract every term of the polynomial. So this means you're subtracting negative 4x, you're subtracting 2x, and you're subtracting negative 5. So I've written that down here. But then I simplify it because I know subtracting a negative quantity is the exact same as adding. So minus negative 4x to the 5th is the same as adding 4x to the 5th. Same with minus negative 5 is the same as adding 5. Now I can combine my like terms. Once again, I've put shapes around the like terms. So x to the 5th, we now have 10 of them. We have negative 5x and then a constant of 5. So this polynomial would be specified as a trinomial with degree 5. On to the next page. So this is just another example of subtracting polynomials, but then adding another polynomial. So once again, as you can see, I distributed my negative to show that I'm subtracting this entire quantity. All right, once I've done that, I'm combining like terms. So I have 6x cubed, and then this is 3x squared. This is negative 14x, and then the lonely 1. So this is my final polynomial written in simplest form. And I can identify this as a polynomial with degree 3. So I'd like you to pause the video and try these for yourself. Once you've tried them both, then unpause to reveal the answers and get an explanation. So hopefully you took enough time to pause the video and try these yourselves. Notice in number 1, I circled the corresponding like terms. So if I were to combine them, I'm left with m squared plus 9m plus 9. And this would be considered a trinomial since it's got 3 terms with degree 2. And in number 2, notice you do have to distribute that negative to each term. So as you can see, if I can pull this down, here we go. So all I did was distribute that negative, and then in the next line, I did simplify, so this double negative does become a positive.
Well, hello.
So once I've simplified that, then once again, I'm just circling the corresponding like terms. And when I go ahead to add them together, I'm left with negative 2n cubed plus n minus 12. Notice the negative n squared plus n squared adds to 0. So I no longer have that term itself. And we can identify this as a trinomial with degree 3. And that leading coefficient here is negative 2. So to summarize, remember only like terms may be combined, and like terms means that they must have the same variable and the same exponent. So for your practice questions, I do ask that you only complete the ones circled, and that includes these questions down here. All right. By the way, this does say perimeter, so keep that in mind. Think about what perimeter means.